The method of clean nuclear energy production through laser beams is very interesting, but at the same time it is very challenging. In fact, with the technologies in our possession, it is not possible to implement it in complete safety and security. Security is not the only area to improve, therefore, in the next few years, greater interest will be needed in the nuclear field in order to succeed in reducing the use of fossil fuels. The clean nuclear fusion with laser beams is an alternative method for the energy production, with a lower cost than fossil fuels and with zero pollution. Since as a waste it is obtained compressed helium, and moreover, being a fusion and not a fission, it produces less waste than nuclear fission. Nuclear is an alternative method of producing energy. It consists in the production of energy following transformations of nuclear atoms. Nuclear is very useful because in the economic field, it causes the cost of electricity production to decrease. The clean nuclear fusion with laser beams also has a defect, safety. Because in case of failure of the plants, they will turn into bombs. But this problem must be solved by investing in research. Fission is the splitting of a heavy atom into two lighter atoms. The mass of the initial atom is greater than the sum of the masses of the lighter nuclei, and the difference in mass is freed as energy. Nuclear fusion is the union of two light atoms that form a heavier atom, whose total mass is lower than the total of the original atoms, and the excess mass is transformed into energy. National Ignition Facility is a research installation on inertial laser boundary fusion at the Lawrence National Laboratory in Livermore, USA. This is their laboratory. NIF uses lasers to heat and compress small amounts of hydrogen until a nuclear fusion reaction is initiated. The system consists of 192 lasers. This is the first instrument from which we are expecting the reach of the objective of a self-helped fusion reaction. Inertial confinement fusion is a process in which the initiation of nuclear fusion reactions occurs by heating and compressing a fuel, consisting of a mixture of deuterium and tritium, typically in the form of a solid microspherula, called target, with inside the mixture of D and T enclosed by a layer of gold. It is the balance between the power fed into the laser and that produced by the nuclear reaction. This goal was achieved in 2013. Once the conditions allow the fusion between the first nuclei of D and T, the radiations released, in the form of alpha and neutron rays, serve to further heat the neighboring areas in the center of the target and thus to start the fusion in a homogeneous way. Once the reaction is triggered, the additional energy of the fusion arises also from the alpha particles, positively charged particles, emitted by an unstable atom. Each superheated D and T pill gives off a burst of energy that can be canalized to heat liquid salt, produce huge amounts of steam that can feed a turbine, create electricity for our homes, just like coal does today, with the difference that this energy would be a zero emission of carbon dioxide, available around the globe, safe, reliable. Also, clean nuclear fusion with laser beams has pros and cons. The pros are solving environmental problems, because it is an energy that does not produce waste like the traditional nuclear fissions, and because they would replace the non-renewable sources like coal. The only counter instead is the security that can be solved by investing in research. The clean nuclear fusion with laser beams has zero cost, because in addition to the cost of building infrastructure and maintenance, the rest is free because paid off by energy. Clean nuclear fusion with laser beams is an alternative method for energy production, with a lower cost than fossil fuels and with zero pollution. Being a fusion and not a fission does not produce waste. The problem is security. With the technological and scientific advancement, one day this problem can be solved by making the fusion nuclear power plants completely safe. For this we need of new researchers who are very interested to this field.